Homework 2.8, Distance, Midpoint, and Circles, Video 5. Homework due Friday, May 22nd, 2020 at 11:59 p.m. The next problem correlates to questions 13, 14, and 15 in Homework 2.8. In the previous video, we learned the equation of a circle based on its center and radius, and we did a couple of examples of starting with the center and the radius and building the equation of the circle. I also mentioned that there are some variations of circle problems. Here's the second such variation. Instead of giving you the center and the radius and asking for the equation, I can give you the equation and ask you for the center and the radius. But in this problem, I'm going to ask you for more than that. I'm going to ask you for the graph and the domain and range, which we will pull off of the graph. So the equation is parentheses x plus 3 squared plus y squared equals 16. So how do we do this backwards? How do we find the center and the radius? Let's start with the radius. The trick to the radius is to remember that when the radius got inserted into the equation, it got squared. So from this, we can ascertain that r squared is 16. And I think you know what we're going to do to that, square root both sides. As a quadratic equation, we should use a plus minus. But in the context of a circle whose radius is positive, we don't have to use the minus. So the radius of the circle would be 4. But how do we extract the center? Well, there's a couple of ways to think about how you extract the center. One is you extract what is being subtracted from the x and the y. Now the problem here is that neither the x nor the y has a minus after it. Could we adjust it and fix that? Actually, yes, we could. Because how could we take x plus 3 and rewrite it as a subtraction problem? We could do something that is rarely done in math. Take a positive and turn it back into a double negative. Now, we don't have to do that, but the fact that we can exposes that the number being subtracted from the x is not 3, but negative 3, which means our center will have an x-coordinate of negative 3. Now, the easy way to pull out the center is just change the sign. Now, over here, there's not even a sign to change. So what's being subtracted from the y? Well, nothing. Literally. We could write y squared as y minus 0 squared. And that's justification to say that the y-coordinate of the center is 0. But in a nutshell, here's how you pull out the center. Change the sign of the number after the variable, and if there's not a number, it's because it's 0. So this circle will have a center at negative 3, 0, and a radius of 4. So let's sketch it. My center is back here at negative 3, and my radius is 4. So let's go up, down, left, and right 4 from here. If we go to the right 4, 1, 2, 3, 4, that will put a point over here at 1, 0. If I go up 4, that's easy. Negative 3, positive 4. Let's go down 4 from the center, negative 3, negative 4. And if we go 4 to the left of the center, we're already to the left 3. And if we go to the left 4 more, we've gone a total of 7 to the left, but we still haven't gone up or down any. Now in the homework, and I'm not going to do a separate video just to show you how to draw a circle in the homework, you'll click a picture of the circle, it will say click the center, and then it will say click any point on the circle. So for homework purposes, you do need to be able to find the location of one of these 4 points. All right, now let's pull off the domain and range. We'll just say d equals and r equals. Even though this isn't a function, it is a relation. Remember, every graph is a relation, and as such, it has a domain and range. but it's a connected graph, so we can pull off the domain and range by looking at the extreme points. For the domain, it's leftmost to rightmost. What is the x-coordinate on the leftmost point? -7. What is the x-coordinate on the rightmost point? 1. Both points are part of the graph, which means we use brackets on them in the interval. And what do you think the range is? Lowest to highest. Lowest y to highest y. The range is bracket, -4, comma, bracket. So pulling the domain and range off of a circle is pretty easy once it's sketched. And if you know the center and the radius, it's easy to sketch. Just be able to pull the center and radius out of a given equation, and you're good to go.